Welcome to the Explainer. Today, we're taking a deep dive into what can sometimes feel like a maze of technical Q&As, and we're transforming it into a complete, easy-to-follow lifecycle map for building an AI project on Azure. Seriously, if you've ever felt totally overwhelmed by the sheer number of AI services, SDKs, and best practices floating around out there, well, you're definitely in the right place. We are going to architect this whole thing, step by step.
So, here's our roadmap for today. First, core AI capabilities. Second, computer vision services. Third, generative AI and Foundry. Fourth, evaluation and prompt flow. And finally, number 5, responsible AI practices. Let's get into it.
Section 1. Core AI capabilities.
All right, before we start architecting, we've got to set our baseline. The source material defines it perfectly. Generative AI uses a language model to create original content in response to a prompt. It sounds simple enough, right? But as you'll see in the Azure ecosystem, this goes way, way beyond just basic chat interfaces.
The ecosystem actually branches out into some highly specialized capabilities. Take speech synthesis, for example. Just picture having an app that reads your emails aloud to you in a perfectly natural, human-sounding voice while you're driving to work. That is speech synthesis in action, and it's a total game changer.
Now, let's demystify 2 vision capabilities that get confused all the time. Say you're building a wildlife tracking app and you need to find the exact location of a specific animal, like a fox, in a photo. For that, you're going to use object detection because it predicts both the location and the class. But if you just need to figure out the main subject of an image, like simply asking, is this a cat or a dog? Well, then image classification is exactly what you need.
Moving on to Section 2, Mastering Computer Vision Services. So it's definitely not a one-size-fits-all situation when it comes to vision. I mean, think about it. Extracting text from a weather street sign requires a radically different architectural approach than, say, finding spatial landmarks on a human face. So how exactly do we tackle both?
Well, for that street sign, Azure Vision's Image Analysis is your go-to service. By calling visual features read, you get the exact OCR text locations back, both in blocks and as individual words. You can even use the dense captions feature to get detailed text descriptions of what's going on visually. But to map out those facial features we just talked about, you actually pivot entirely over to the Azure Vision Face service, which specifically returns landmarks for those spatial points on a face.
And here's the best part. When you're creating these custom vision solutions, you don't have to sit there and manually label thousands of training images. Nobody has time for that. Instead, step 1, you just tag a few images with objects of each class. Step 2, train an initial object detection model. And step 3, you take advantage of the Smart Labeler tool to handle the rest. It is a massive, massive workflow accelerator.
Okay, but to actually wire this into a client app, you have to create separate custom vision resources for training and for prediction. The critical mistake developers make here, they try to use the training credentials for the client app. Don't do that. Your client app specifically needs the endpoint and key for the prediction resource. Combine that with your project ID and your deployed model name, and you're good to go.
All right, Section 3, Generative AI and Foundry. Welcome to the engine room. Here are your Foundry fundamentals. First, you host OpenAI models via a standard deployment. Then, your code acts as a proxy using the AI project client, which you instantiate with your project endpoint. Need to customize the responses and dictate the AI's persona? Just tweak the system message. From there, you're chatting via the Azure OpenAI SDK, and you can test the whole shebang directly in the chat playground. It is incredibly seamless. Now, as we look at making these generative models truly useful for real-world business applications, we run into a major hurdle. We have to ask, what does groundedness actually refer to in this context, and how do we stop the model from just making things up?
So grounding literally means using your own data to contextualize prompts and ensure relevant responses. Architecturally, this relies heavily on the Retrieval Augmented Generation, or RAG, pattern. To implement this in your code, you basically just add your index connection details right into the OpenAI chat client. It's like giving the AI an open textbook to read from before it answers you.
But what if grounding isn't enough? Well, if RAG is giving the model an open textbook, fine-tuning actually changes how the model inherently needs to act. Step 1, you format your training data in JSON-L. Step 2, you use fine-tuning to optimize the specific behaviors. And Step 3, you set a parameter called n_epochs. This simply dictates one full cycle through the training dataset, so the model learns exactly how to behave.
Which brings us to Section 4, Evaluation and Prompt Flow.
You can think of prompt flow as the glue holding all this together. You start by creating connections to securely call your deployed models from Azure OpenAI. Then, you deploy that flow to an endpoint so you can integrate it online, like into a website. But listen, here is the golden rule. If the flow underperforms after deployment, don't try to hack it in production. You've got to revert back to the experimentation stage.
But how do you actually measure that performance? Well, you have to choose your evaluator carefully. If you need to judge the structure and logical flow of ideas, use coherence, which actually uses an AI model to grade it. Pretty cool, right? But if you need to compare generated responses to a strict ground truth using standard metrics, you'd use the F1 score. And of course, keep in mind that manual evaluations are always there for applying that necessary, nuanced human judgment.
Finally, Section 5, Responsible AI Practices.
Putting AI into the wild starts with an AI impact assessment. And make no mistake, this isn't just some legal paperwork. It's a crucial exercise where you document the precise purpose, the expected use, and most importantly, the potential harms for the generative AI solution. You have to map this all out before a single line of code hits production.
Once those risks are identified, we set up safety and delivery guardrails. We use content filters to mitigate harmful content generation right at the safety system level. Then, you roll the whole thing out using a phased delivery plan. This enables you to gather feedback and identify any unexpected real-world issues in stages, way before you do a broad public release. We've just mapped out the entire architectural blueprint, from Gen AI basics and custom vision, all the way through RAG grounding, evaluation, and safety guardrails. So with the full power of the Azure AI ecosystem at your fingertips, which real-world problem will you solve first? The infrastructure is no longer the bottleneck. It's totally up to your imagination now. Thanks so much for joining me on The Explainer today. Keep building, and I'll see you next time.